what we want to do next is look at some of the ways that we can use our ratio identities, reciprocal identities, and Pythagorean identities. Here's our first problem. If sine theta is 4/5, find cosecant theta. Well, we've memorized that sine theta and cosecant theta are reciprocals. That is, cosecant theta is always equal to 1 over sine theta. That is one of our reciprocal identities. That means that, in this case, cosecant theta will be 1 over 4/5. When I take 1 and divide by 4/5, I multiply by its reciprocal, and I end up with 5/4. We could, of course, go directly from here to here and skip showing that work right there, because we know that cosecant theta and sine theta will always be reciprocals. That means that their product is 1, so if one of them is 4/5, the other one must be 5/4. Here's our next problem. Find cotangent theta if sine theta is equal to negative 5/13 and cosine theta is equal to 12/13. Well, I know from my ratio identities that cotangent of theta is always equal to cosine theta divided by sine theta. Cosine theta divided by sine theta, in this case, cosine theta is negative 12/13. And sine theta is equal to negative 5/13. So I end up with negative 12/13 divided by negative 5/13, which is going to be negative 12/13 times the reciprocal of 5/13, which is, negative 13/5. Negative times a negative is positive. My 13s divide out, and I end up with simply 12/5. So a little review of fractions there for you at the same time. But the main point here for trigonometry is that the cotangent is always the cosine of theta divided by the sine of theta. In this case, that's negative 12/13 divided by negative 5/13. I multiply by the reciprocal, I end up with positive 12/5. So anytime you have the sine and cosine, you have the cotangent. And of course, then you also have the tangent, because tangent and cotangent are reciprocals. Here's our next one. Find cosine theta if sine theta is 1/3 and theta terminates in quadrant 2. Well, I have a Pythagorean identity that tells me I can find the cosine if I have the sine using this identity. Cosine of theta is equal to plus or minus the square root of 1 minus sine squared theta. That's an alternate form of my Pythagorean identity. My basic Pythagorean identity says that sine squared plus cosine squared is always equal to 1. An equivalent form is that cosine theta is plus or minus, depending on what quadrant we're in, the square root of 1 minus sine squared. So let's take a look. Because theta terminates in quadrant 2, and I'm looking for the cosine, I know in quadrant 2 cosine is negative. So I'm going to choose that sign, square root of 1 minus sine squared. Well, sine is 1/3, so its square is 1/9. So that's going to be negative square root of 9/9 minus 1/9 is 8/9. So I'll take the negative square root of 8 is going to be 2 square root 2 when I put that radical in simplified form, and the square root of 9 is 3. So if the sine of theta is positive 1/3, and theta terminates in quadrant 2, then the cosine of theta must be negative 2 square root 2 divided by 3. Here's our next problem. If cosine theta is 12/13, let's make sure you can read that, 12/13, and theta terminates in quadrant 1, well, that's good. That means that all 6 trig functions are positive because we're in quadrant 1. Then let's find sine theta, tangent theta, cotangent theta, cosecant theta, and secant theta. Okay, well, sine theta, I'm going to use my Pythagorean identity. Since theta is in quadrant 1, I know I'm going to have positive square root of 1 minus cosine squared. That's 144 over 169. So that's going to be the positive square root of 169 over 169 minus 144 over 169 is going to be 25 over 169. And so that will be the square root of 25, which is 5, square root of 169, which is 13. So if cosine theta is 12/13, then the sine of theta must be 5/13, and I know it's positive because theta terminates in quadrant 1. That means that tangent theta is, well, how about if I use my ratio identity? Sine theta over cosine theta. Sine theta is 5/13. Cosine theta is 12/13. 5/13 divided by 12/13 is 5/12. So that's my tangent theta. Cotangent theta is the reciprocal of tangent, so it must be 12/5. Cosecant theta is the reciprocal of sine theta. Sine theta is 5/13, so cosecant theta must be 13/5. And my last one, secant theta, is the reciprocal of cosine theta. Cosine is 12/13, so secant must be 13/12. So here's the point of these identities. If we're given any one of the trigonometric functions, in this case cosine theta equal 12/13, and the quadrant in which theta terminates, then we can find the other 5 trigonometric functions of that angle. All we need is one trigonometric function, and with our identities we can find all the rest of them.